You guys all hear me now in the back? Okay. I'll just go ahead and get started again. My name is Kris Moore. I'm with the PC-BSD project. Today we're going to be discussing our new installer backend for performing the system installation of PC-BSD, which also can be used to install FreeBSD. First thing you're going to ask is why another installer backend? There have been numerous projects to do this in the past. We've even had our own in previous versions of PC-BSD, and we just decided it was time to embrace something new and add all the new features we were looking at. But first, let's look at some of the weaknesses of our old backend and why we didn't continue on development of that. First of all, it wasn't a full backend where you could script and support and do automated installation. That was a biggie. We weren't going to get that feature. It was difficult to add new features for a few reasons. Most of the logic was done actually in C++ under Qt and then passed on to some scripts, so they kind of juggled tasks, and adding new stuff to that was just a pain in the rear. You'd be toggling between shell scripting and C++ back and forth. There was no logging, so as soon as it failed, we had no clue as to why. It was very difficult to work on debugging, and it was completely monolithic. Nothing was modular in any way. So when we started thinking about a new installer, we started thinking about some of the features we'd like to see implemented in it. The first thing we wanted was a modular design. Next, of course, scriptable installation was a biggie. We really wanted that for 8.0. We wanted the ability to support multiple front ends. We didn't want our installer to have an end of life just because we wanted to put a new GUI on the front of it. We still wanted to re-implement and keep the back end. Of course, error logging. So now we wanted the ability to see what's going on the hardware and find out where there's problems. And file system support, there's a lot of new exciting stuff going on. FreeBSD with ZFS and journaling and all the GUI classes. We wanted to be able to take advantage of those. And another cool feature, most of you guys are probably interested in this one, is the ability to install FreeBSD versus PC-BSD. This came up actually at AsiaBSDCon, and somebody suggested it, and we were like, that's a great idea. Why didn't we do that years ago? But that was an idea we wanted to have implemented, and then better localization options for people running in non-English languages. So when we started development of this last summer, we started looking at some of the design choices. How are we going to implement this? How is it going to be done? First thing we wanted was a different model. We wanted a hybrid program flow. And what I mean by that is the back end is not driving the front end, and the front end is not completely driving the back end as well. They interact in certain ways, but it gives us more flexibility in designing our GUIs or other interfaces to the back end. For example, the front end can now decide, okay, how are we going to do the disk layout, and we could present it in a way to the end user which fits our target audience or that particular language we're developing in. Another thing we wanted was the ability to use the back end manually, and with the back end separated from the front end in this way, you can actually run it in a manual manner, kind of offline mode without any front end whatsoever. The next thing we wanted was to make it portable. So, we looked at some options and ultimately decided let's write this in shell using standard binsh, no non-standard base system tools. We wanted this to run just on a vanilla FreeBSD right out of the box. That way there's no fighting over we need to include X app or port or this isn't BSD licensed, etc. So it's written basically using binsh, sed, awk, cut, all the standard tools and stuff. Also, we wanted this because it's easy to debug on the fly. I can essentially boot it up in VirtualBox, make mods, add new features, SSH out of the VirtualBox, and commit it, and we're good to go. And I can test it right there without having to go and recompile something and not having those tools maybe in my boot image. And we wanted this because it would have the variety of front ends that could be used with it as well. We're not forcing you to use a certain development library or a certain interface to talk to the back end. Pretty much anything should be able to communicate with this. Here's some of the features we ended up actually putting into it, and this is actually active right now on PC-BSD 8.0. The first thing is you can install PC-BSD or traditional FreeBSD. So if you're looking for vanilla FreeBSD 8.0 P2 installation, we can do that right now. Support for enabling Gmirror across 2 drives. We just added that in 8.0 as well. So Gmirroring will be set up. It'll create all the devices, set up your FS tab properly, etc. And then of course you can go in and add more drives to it down the road. We are now able to use quite a variety of different file systems. Standard UFS, soft updates, gjournal, and ZFS support right out of box. We've added support for Jelly, so if you're looking to do some disk encryption, that is now an option. And we've also implemented file system labeling with glabel. This was a biggie, and a lot of people have requested it. We see a lot of cases where end users will go and yank a drive out because they're dual booting Windows or something, and when they yank it out, it's renumbered and you can't boot, and try to explain that to a Windows guy with that mount root prompt means that's a pain in the rear. And we've added the installation logging now, and we've added options to install via disk and network, and you can install your own custom images. So if you've rolled your own FreeBSD image or you have a backup, you could potentially restore it using this backend. Using your actual backend is fairly simple. If you have anybody has a disk or wants to get one upstairs, we can show you this. When you boot up the disk, it's under PC-BSD, PC-SYSINSTALL is where it's located actually on the boot media right now. And that can be changed to run whatever path you want it. There's just one command. You run a PC-SYSINSTALL. It provides all the functionality from querying to the hardware, what kind of hardware is on this system, how many disks are available, what layouts are on the disks. All that information is right there with that one command. And then it actually performs the installation as well via a past configuration, which we'll look at again in just a moment. There's a lot of various commands and flags. We'll look at just a couple of them here, but there's quite a few, not too many to get into today. First of all, here's some of the basics. If you want to run in an offline mode with no front end, this is the way to do it. We have query commands, listing of your available drives, disk partition information will just return everything about the disk. Is there free space on the disk? What partitions are there? What are they formatted? Etc. We have information on all the time zones, just in a neat format, telling you, hey, here's the available time zones you can use for installation. If you're doing an installation of PC-BSD or something with Xorg, we can even query and return all the keyboard variants and information that Xorg supports as well. Now, the actual install file configuration, I just want to go over this just a little bit before we actually look at some examples. The configuration syntax was designed to be somewhat similar to sysinstall, so it's not a huge learning curve if you're coming from doing some scriptable sysinstall. It just uses a very simple syntax, key equals value, nothing too exciting there. We have a whole bunch of examples in the examples folder of different types of installations from GMIR to ZFS. You can look at a real live example to see what it does and then modify it to suit your needs. And then there's a big README in there with information on all the various keys and what they do and code blocks. Now I'll actually take a look at the config file though. This is the start of a configuration file which the front end would take and generate based on user input and then save it to disk and tell the back end, hey, let's run with this and perform the actual installation. You can see it's very, very basic, not too difficult here. We're telling it install mode. We're doing a fresh install. The back end actually supports doing upgrades as well, which essentially just preserves your home directory's passwords, a few different configurations. We're telling you what we want to set the host name to. It can be anything you want. What type of installation we're doing. You can toggle that between FreeBSD and PC-BSD if you're booting off our install media. Where we're installing from is a DVD, not a USB in this case. And what the package type is in this case, we ship with a tarball, the FreeBSD clean world ready to go. And then we have a components section as well where you can tell it, hey, we want to install ports or install system source. If you're installing PC-BSD, you can list our optional packages there too, like Firefox, OpenOffice, etc. It'll handle all the installation of those. This is where we get into a little more interesting stuff. This is the disk configuration, how this works in the U configuration file. As you can see here, we've defined disk 0, so you're going to start with 0 and work your way through the numbers there. Set it up as AD0. And the partitioning here, we have a few different options, all which runs in dedicated mode. Free space, so if you actually have some free space on the disk, you can say, hey, take that and turn it into a partition. It'll figure out or slice, it'll figure out what number to assign it and go from there. And then you can target a specific slice if you're installing on a system that's already got an operating system. In this case, we're doing a couple of special things. We have mirroring enabled. And you can see it's very simple to enable. You just tell it, hey, this is the disk I want to mirror with, and here's the method I would like to use for balancing. Next thing is the boot manager. Again, very basic, just BSD or none. And then this is a special flag here we've given it, commit disk part. This says this disk section is done. We are not going to be giving any more configuration options to this disk. Now related, underneath here, now that this section has been defined, we come down to the actual disk label where we start setting up our individual partitions, and this is going to relate up to the disk name up here. So disk 0 is going to equal AD0 in this case, which is pretty cool because if you have some of these defined, now you can just toggle the name right up top and say, hey, just take this from AD0 to DA0, and the whole same configuration will work. We're defining here a UFS partition. We're telling them we want soft updates, 500 megs on slash. We're saying, hey, here's swap, 2 gigs, no mount point obviously, and then ZFS with the remaining disk space on user. And then we can commit it here, and that says we're done defining partitions for this disk. One special thing to note here, if you notice in the comment here, these are the different types of file systems. You can just add a .eli to any of those, and that's all that is required to enable Jelly support. So very, very simple. Here's some more information on the configuration. This is for network setup. This is some interesting stuff here. We have a couple special options here. The first one, we set our net device. And we have a special flag, auto DHCP, which is great on a desktop. You just want to say, hey, go find the network device and set it to DHCP. That way we're ready as soon as we boot up. Or if you want to manually specify, you can go ahead and do so at this point. And this is for actually during the installation. This will get set while the installation is working. So this would be a great example if you're doing a FTP install and you want to bring up this interface with this address to perform a network installation. And then we have a different flag, which is similar, but it just says net save dev. And that means save that to the actual disk when we're done. This is the configuration we want on the installed system. Same syntax, so you can have the same flags for the save dev. Username setup, very basic here. You set up your name, comment, password, shell, home, what groups you want to be a part of, and then again the commit flag, which tells us that we're done defining information for this user. Go ahead and save it to disk. And then our localization options, this will probably be more applicable to installing PC-BSD because some of this is for X, but you can localize your language here, and this will set that up on the console as well as for X if it's available. Your keyboard layouts, your models, your variants, that can all be specified here. And again, if you query the backend beforehand, you can see the list of what's available and just change that flag to what you're looking at installing with. We have a couple interesting things here we've added that we use in PC-BSD. We have some options for running commands. So if you have your own custom scripting or commands you'd like to run, we can take advantage of that as well. The run command flag. This actually says run this command inside the mount after we've done installation. So if you have some post-installation setup you'd like to do of your system, you can run a command here, or it could be a pointer to a script you've included in your install image, or whatever it is you want to run. Run script is pretty much the same thing, except this will be if you have a script on your install media somewhere and you want to say, hey, copy the script into the bootable system and run it from there. So it'll handle the copying, it'll find where it's mounted and handle all that for you. Now this is actually, I just want to show you here how this actually works. You talk about, this is what we do. This is what it actually does on 8.0 if you tried it right now. You can see this is the front end. This is what your end user is going to see. When you boot up PC-BSD, you're going to see this. This is all written in Qt. And at this point when it's come up, it's already queried the back end to see what's available. So it knows, here's what we got. Now it's going to perform the logic to what the user set it up. Here's a neat trick I want to show you though, because this may come in handy. When you get to the summary screen, after you've set up all your disks, you've set up all your users, and you're ready to actually start the installation, if you actually stop at this point, right-click on the desktop, bring up Xterm, you can look at the configuration. It's saved at this point. And you can take a look. This is what the GUI has generated. It has gone ahead and set up all the options I told it to for the installation, and you can make mods to it at this point. The GUI, I kept that in. We're thinking about adding a debug option at the bottom too, so you can just automatically open that up in VI or something. But this will let you go in if you want to make adjustments to it manually, something that the GUI doesn't offer. There's still a lot of ways you can work with this. And then when you're done, you save it, you say start the installation. It'll use whatever config you've modified. Future editions. These are some of the things we're looking at adding in the future, and this may change depending on feedback we get from users, since this is really new. First of all, lots of bug fixes. This is all brand new, so we're finding and fixing bugs like crazy. The other thing we're looking at is support for encryption passphrases. Right now, we're just generating a random key and then saving it in your boot directory, and you need to back those up. We'd like to add support where you can just specify the passphrase, but we're dealing with a limitation with Jelly at the moment on scripting that in. We need the ability to create and delete slices on the disk right now. Right now we just take advantage of what's existing or run in dedicated mode. We're going to have to add some support for tweaking that manually. Advanced ZFS options, these actually we've already committed about 2 weeks ago. Now we have the ability, and I'll show you this here in a second. For ZFS, when creating the Z pool, you can list other drives, like if you want to set up a RAID Z, you can list all the other drives to throw into that RAID Z or a mirror. You can now list that in the configuration. It'll automatically set it up for you. And we've added options for specifying multiple ZFS mount points as well. So it's not just setting up one partition and mounting it to a certain location. We've also switched, this just got put in recently, to using GPT. So when you run in dedicated mode now, it's not using the standard BSD label, it's running in GPT mode. And we've had some requests for more FreeBSD specific options, like setting up SSH, some additional networking setup if you want different types of distribution stuff on the actual installation. But let me go ahead here real quick and see if I can do this. And it's all nice to talk about it, but it's cool if you can actually show. I apologize in advance if this crashes. I've had a couple cases with ZFS dumping inside a VirtualBox and locking up, so hopefully that doesn't happen. Okay, this is actually booted up off our install video right now using the latest installer from Trunk. And if we go ahead and look here, it's really just running Fluxbox. You can see the GUI's up and running. I've bypassed it all for the purposes of this demo. We'll go ahead and look here. Okay, so this is the configuration. I've supplied it saying this is the type of installation I'm going to do. This is a live example. This is what you're doing if you want to perform this installation. You can see most of these options are ones we've looked at. I'm setting everything to DHCP on the system. Where am I located? Do I want NTP enabled? That's another feature we can set up for you. Disk Manager, here's some of the new features I was talking about with ZFS. If you'll notice here, we've said take this entire disk, the entire size of it, and create these mount points within a Z pool. And we want to create the Z pool with a mirror, AD1 in this case for this example. And you could list 5 drives, 10 drives, or whatever it is you're doing. You could toggle that mirror to RAID Z if you wanted, and it would set it up in RAID Z mode. Down below it, we actually have a few different drives in this VirtualBox session. We've set up another drive, and we've said, okay, now that we're done with the first one with all our ZFS, let's go down here on 83. We're going to set up a swap on 83, and we'll set up just some generic UFS data or something, just for the purposes of the example. And let's see, what else we put in here? Optional components. I didn't specify any username, password, root password. This all gets obliterated at the end of the installation, so just don't keep your config laying around. But that's it. Let's see here, where are we at? Okay, this is the PC-SYSINSTALL directory, if you guys can see this. It's very clean, very simple. We have 2 different forms of backend directories. We have one with all our query commands and one with all our actual installation. If you run PC-SYSINSTALL by itself, it comes back with all the usage information, all the different flags that are available and what they do and what they return. So if you're looking at developing a front end, this would be the great first place to start. Okay, and then in examples, again, various installation example options. So the one I've shown you today, we provide many defaults, so you can actually try your own and base it off of one that's already built, along with the README that goes into all the details on all the various flags and what they do. Starting an installation is pretty simple. This is all that's required. We've told it, okay, here's the configuration file. Let's go and actually make this happen. Let's do the installation. We start by doing some sanity checks on the config to make sure you didn't really make some boneheaded mistake, really bad typo, whatever. It may not catch all your logic mistakes, so if you tell it to work on some disk partition, there's not enough space in there, it'll determine that later during the installation and fail somewhat gracefully. At this point, it's going ahead and actually performing the installation. We've set up ZFS, we've set up UFS on the different drives, and let me see here if I can show you. I'll wait for this to finish here. It's going ahead and creating the different mount points in ZFS. Right now we default to using tank 0 as the default name for the Z pool, and then it'll, if you have more, it'll tank 1, 2, 3, 4, etc. And it's actually performing the installation of FreeBSD right now. We go ahead and look here. Hopefully you can see this back here. You can see everything's been mounted now. So they're mounted on MNT currently. That's what we default to. That can be changed in the configuration pretty easily. we've created all our mount points, and we're doing the installation of FreeBSD now. And while we're waiting for that, it'll take about 2 or 3 minutes. If there's any questions while we're waiting for that to install, I'll be glad to answer them. Then we'll reboot and actually show it booting into FreeBSD to prove that it works, hopefully. Any questions?
Yeah. You've moved from MBR to GPT, you said. So far I've not found a way in GPT to do multi-booting.
Dual booting with other systems?
Yeah, or multiple BSD versions.
It does the method where it puts the MBR on first and then uses GPT for the rest of this. That's for dedicated mode though. If you want to do across the entire disk, it does use BSD labels still if you're doing dual booting. So if you tell it to install the second partition of a disk that has Windows on it, it'll still revert back to the traditional MBR mode. It's not going to force it to go to GPT.
What version of PC-BSD now moving?
What was that? This is installing FreeBSD 8.0 right now. I'm not installing PC-BSD. It'd take a lot longer to install. It's a much bigger image. So I just wanted to do a quick demo.
Quick demo?
Yeah.
8.0?
8.0 P2. Because we released 8.0 6 months after FreeBSD 8.0 came out, we were able to include the security patches, which is one thing that's nice. We have that option now. We're not going to release day and date with FreeBSD. So when you guys find a major security bug, we can go ahead and compensate for that, throw the patches in, and then roll with our release. Okay, so it's just about finished here. We've actually extracted, and you see it's pretty quick. It doesn't take long to do a FreeBSD installation. Let's go ahead and shut this virtual machine down.
Where was that booted from originally?
It was just booted off an ISO in VirtualBox.
Okay. CD image.
Yeah, just CD image. Yeah. And let's go ahead and go back to full screen here. See if it'll boot back up on FreeBSD, and it should be in good shape. This is our stuff in trunk, so I apologize if something doesn't work, but it did work when I tested it at the hotel. Is there any other questions? You see, this is so we've just done this is off the PC-BSD installation CD, so we've performed a vanilla FreeBSD installation at this point, and it's going to go ahead and just boot up here with all our ZFS, G-label, etc.
I want to read the document of that PC-SYSINSTALL configuration file. Is there manual?
The examples directory, the README in there, has pretty much all the information you'd want. We're looking at something I need to do. It's on my list to set up a big wiki page on our site. And first thing I'm going to do is copy that README over and start adding that info. Okay, so we've set up FreeBSD. We're all good to go. And we check here. You see FreeBSD installation using ZFS. Everything's mounted. You can see the label was set up properly using G-label for UFS partition. And it's ready. At this point, you're good to go. You can start running, do what you need to do. So that's pretty much all I have for you guys today. Unless there's any other questions, I'll be glad to answer. Yeah.
In the Chrome code, like for the network interfaces,
yeah.
Can you detect which interface has a cable?
We could add that in. It doesn't do that yet.
It seems like that would actually be what you really want.
Sure.
Does EHCP, whatever interface, actually is active?
Sure. Yeah, we can do that. That would be real easy. It's a shell script, so just go in, add that in. If it's active, mark it up and go. So, again, see, those are the kind of features I need feedback from that you guys will think of and go, hey, let's do that. So that'll take me 5 minutes to put in. We'll do that for 8.1. Any other questions?
They are installing only from different RAID arrays. So RAID Z, Mirror, which other supported?
Just RAID Z and Mirror at the moment. Those are the two, although we can add any other ones we want fairly easily. Again, I just put this in last week, so it's still pretty fresh.
Is there any ability to do like special configuration for ZFS, like memory tuning or the LTR? How big it is?
It's not going to do any automatic memory tuning for you at that point. We'll assume if you're trying to set that up, you can provide your own image to install. You don't have to install our image. You could roll your own tarball and dump it onto a network folder and extract that with your customized kernel, etc. It's not going to do any custom kernel setup or memory tuning right out of box. Although again, with the options to run scripts and commands, you can do anything you want with that. So any cases I'm not anticipating, you can easily supply to it. Any other questions?
Can I do the same installation by GUI installer?
For the most part, some of the options have not been put in the GUI yet. We have just added the advanced ZFS options into the GUI, but that's not in the 8.0 DVD. That's going for 8.1. But yeah, most of the options you can do via the GUI. And again, if there's some special option you weren't able to set via the GUI, you can open it up, add it in the config, and let it run. Yeah.
The interaction between your front end and the back end is only through the configuration file, or is there more interaction?
Just to generate the configuration file, really. The way it works is when a GUI or any front end, it could be command line, when they start up, they're going to go through and run all the probe commands, checking to see what hardware is available, what disks are available, what partitions are on them. They'll then take that and allow that front end to run its own logic to present that to the end user. And then when it's done, it just kicks it back to the back end and says, here's the config, run with it. So essentially, every installed PC-BSD at this point is a scripted install. That's all the front end is doing, is generating a script, and so they do the scripted installation.
The probes are part of your installer.
What was that?
The probes are part of your installer.
Yes. Yeah. Then I'll go ahead and do that. Anything else?
Yeah.
Okay.
This is not directly related to PC-BSD, but I guess the important things. I know the IX systems said to support the freeness project.
Yes.
And to bring PC-BSD technology to freeness. And for example, a modular basis GUI technology or something PBI systems. So I want to know some topics around that freeness.
You would have to actually contact our Matt over at IX. I haven't been working on that in particular. They're welcome to take any of this and I'll help them bring it over, but I have not been a part of that just yet. I know some of the guys down at the office are working on the freeness stuff. Any other questions? Cool.
I noticed the MOTD still tells you to sysinstall.
Yeah. This is FreeBSD, so you have all the same stuff. We're not touching the MOTD or anything. I didn't want to have all the cries, you messed with my traditional FreeBSD installation. No, this is a generic kernel, generic everything. We have not monkeyed with your FreeBSD in any way. Well, if there's no other questions, thank you guys very much.